Hey folks, how's it going? It's Mr. Murray here with the video on volume and surface area of pyramids. So as the title of the video suggests, what I'm going to be doing here is breaking down for you how we find the volume and surface area of any 3D pyramid. And pyramids are actually pretty cool shapes, and you'll find that actually you can get a lot out of the formula that we're going to do today, but we've seen them all over, right? From pyramids in Giza to pyramids on this nice little fractalized broccoli, to even in chemistry, atoms arranging themselves in a pyramid like kind of orientation. All right. And so I think they're actually pretty cool. And so I'm excited to share with you some interesting facts about pyramids. So I thought that I would start by talking about the volume, right? Because we probably want to start by asking ourselves, how much can we fit inside of this pyramid? Now, before we start about that, there's a couple things I do want to point out. So you'll notice here that I've got this pyramid and it's been labeled with a couple of things here. So you can see that I wouldn't focus on the perimeter, but you can see we have a height and we do have a base. There is a notion of a base. This is considered a square, or sometimes people may call it a rectangular pyramid based on its base, right? As with like a prism, right? Prisms can have any kind of shape for their base that you want, and in theory, a cone, a pyramid could have lots of different shapes for its base. In fact, when it's a circle, kind of reminds me of a cone, as I kind of gotten at earlier. Also, between the base and what we call, sometimes people call this the apex, okay, you have what's called the slant height, and that just is kind of like a measurement of how steep the pyramid is. Sometimes this number is given to you, or sometimes you need to figure it out based on other information. Okay, so what we need to do is we need to start by thinking, how could we do the volume? So to figure out the volume, what I've actually done is I've encased this pyramid inside of a prism. Now, what we know about a prism is we know the prism has a volume of length times width times height. We know that already because that was in our initial investigation of volume. Now, as it turns out, this prism has been carefully designed such that I've actually taken the pyramid, and reproduced it 6 times. So I've got it as you see it here. Then I've got this other little pyramid. You can see they're kind of like marked off. You can imagine like a pyramid, like where this is the base that I'm shading in the purple. So that's a second pyramid. You can imagine another one where this is the base on top. That's 3. Then you could imagine one where this backside is the base. That's 4. And then you can imagine, so we've got 1, and then this backside that's kind of difficult to see back there. So we actually have, let's see. Well, as it turns out, if we just go back and use the faces of the cube, right? The faces of the cube correspond to all of the different bases of the pyramids that are making this shape up, right? So there's 1, 2, 3, 4, 5, 6 faces to this prism. Please confirm that you know that there are 6 pyramids that are used to make up this prism here. Okay. So if I look at the length times the width times the height, what I know is that the pyramid is a 1/6 of that. Why? Because there are 6 pyramids in the entire prism. So if I want to know the volume of one, what I'm going to do is take the volume of the whole prism and divide by 6, or in other words, multiply by 1/6. Okay. So remember, this height is the height of the entire um, of the entire cube or prism, not the height of the pyramid. Just be aware of that. All right. So, as it turns out, because of the way we've designed it, if you think about it like this, if you imagine this other prism like that's like stacked on top, so they meet at this one point, well, what you can see is that the height of this pyramid is half the height of the entire prism, right? So let's just split off this 1/2, because it doesn't really matter what order you multiply things in. But remember, if I split it up like this, well, this is the height of the pyramid. Now remember, we know that volume is base times height. So let's see if we can find the base of the pyramid. And of course we can, because the length times the width of this cube is the same as the base of the prism. Okay, so the L and the W match up with the L and the W of the pyramid, so they don't need to be repeated. But what this tells us, okay, is that the area, or rather the volume of a pyramid is equal to 1/3 of the base of the pyramid, which is length times width, times the height of the pyramid. Now, remember here, the H, when I talk about H, in this case, H is the height of the pyramid. In this case, H was the height of the prism. So I want to make sure I specified that so you didn't get those two H's confused. Okay, so essentially this is what we need to do. If I want to find the volume of a pyramid, I take its base, the area of its base. So remember, B is the area of the base. I multiply by the height, right? And then it's 1/3 of that. And we've proven that by using it, a bunch of them, to construct a cube, or I guess in this case, to be precise, a prism. And then we use a dissection of that prism because we can use the area formula that we already know to figure out the area of the pyramid. All right, so you don't necessarily need to know how to derive the formula, but you do need to know that the volume of a pyramid is 1/3 times the area of the base times the height. All right, so here's a question. A piece of pure silver in the shape of a rectangular pyramid with the dimensions shown has a mass of 19.7 grams. What is the density? So notice how they use the word rectangular pyramid. Rectangular tells us what kind of base we have, okay? Because remember, we need the area of the base. So the fact that it's rectangular, remember, we need to know that first of all, right, we need mass over volume. So we know that the volume now is 1/3 times the area of the base times the height. Now the area of the base is 2.5 times 1.5. And then the height is 1.5. All right, let's go ahead and get this set up in our calculator. All right, folks, here we go. I got my calculator here, and let's go ahead and plug away at this one. So I've got 1/3 times 2.5 times 1.5 times 1.5, right? Ooh. Right? 1/3 the area of the base times the height. And I get 1.875. Now, we got to be careful. Let's be very careful of our units. Centimeters cubed, because remember, whenever you're doing volume, you need to have cubic units. So unit cubed, meters cubed, centimeters cubed, whatever it is, cubed. Okay? And now I need the density of silver. So the density of silver is going to be 19.7 grams per 1.875 centimeters cubed. That is how you do density. It's always grams per centimeter cubed. Okay, folks, so 19.7 over 10 point, so they want to the nearest tenth, 10.5 grams per centimeter cubed. All right, so now we've talked about volume. What about surface area? So the thing about surface area here is it kind of depends. Now, there's really all types of pyramids you can have, right? A pyramid is actually pretty loosely defined. So it essentially comes down to the fact that we have 5 sides that are connected. Okay, so we have what's called the base, and then we have what's called these 4 so-called lateral sides. So in general, the surface area is equal to the base area plus the lateral area. And when you think lateral, think side. Like if you ever seen in like football how they do a lateral pass it to the side, right? So the 4 sides. Now, if all 4 sides are congruent, then it's just a matter of finding one of the areas and multiplying it by 4. What I'm going to do, because there's so much variability, is do an example later on to show you how to find the surface area. The last thing we can deal with, and this is true of any kind of 3D shape, is a composite figure. So when you have a composite figure, that is essentially, right, a combination of multiple different shapes. In the example you see here, it is a prism and a pyramid. And what I've essentially done is I've taken a pyramid and I've taken it like almost and like stamped it in there and like pulled out a pyramid sized chunk from this prism. So what you can see here, how we figure out the volume is, well, we take the entire volume of the prism, which is given by length times width times height, and we subtract the area that I cut out. Okay, now similarly, imagine if it was on top. Then instead of subtracting, I would be adding. Okay, so you just have to, and I don't want to put anyone down, it's just kind of using like common sense. Looking at the shape, am I taking away volume or am I putting in volume? Look for keywords like removed. Removed, you think subtract. Okay, so let's take a look and see if we can find the volume of these composite figures. So remember, we know that at this point that the volume of a pyramid is 1/3 the area of the base times the height. And in this case, what we know is this. The base of each of these pyramids is a square with a side length of 6 inches. And each of the pyramids has a height of 8 inches. Okay, so let's take a look and see if we can figure anything out. Now, typically, what I'm going to do is I'm actually going to find the volume and the surface area. So typically to do this, what you need is what's called the slant height. It's called the slant height. Okay. And the slant height, we need that because essentially we're breaking down this into 4 of these triangles and a square base. Okay. And I'll show you what that looks like. So we need to find the total volume, right? And we have 2 pyramids. Each base is a square. And you have these side lengths given. So I'm going to interpret it as this. I'm going to take the 2 volumes and I'm going to add them up. Okay? Be aware there will be surface area problems as well. And I'm going to incorporate that by finding both. So first, the volume. So the volume of each one is equal to 1/3 times the area of the base, which is a square. So you multiply 6 squared times the height of 8. Okay? That will give me that. And now this is something that I will plug into my calculator. Okay, folks, so here I go. I got my calculator here. So I'm going to do 1/3 times 6 squared times 8. No. There we go. Times 8. It's gonna give me 96. I'm gonna take that and I need to multiply by 2 because I've got 2 of these pyramids. And that is gonna give me 192. Notice the units inches cubed. Okay, surface area. So if you look, now I don't have the slant height, but we can figure it out if we assume that this is midway down the line. Then we have a length of 3, a height of 8, and then that allows us to use the Pythagorean theorem to calculate the remaining side. Because you have 8 and 3. So the slant height, let's call that S, is equal to 8 squared plus 3 squared. So S squared is 73. So S is equal to the square root of 73. And now we do base times height divided by 2. So in other words, 6 times the square root of 73 divided by 2, which is 3 times the square root of 73. Now I've got 4 of those because there are, actually I have 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. And there are no outward facing bases. So it's actually only that. So therefore the surface area, I'll do this up here, is equal to 8 times 3 root 73, or 24 root 73 inches squared, because it's area when you do that with squared. Okay, so remember, it didn't originally ask for that, and in all honesty, I did pull this from the textbook, and the textbook only did volume. Okay. All right, now I'm going to go ahead and we're going to talk about the next composite figure. I'm going to turn this one over to you. The composite figure here is formed by a rectangular prism with 2 square pyramids on top of it, as you can see here. What I want you to do, pause the video, find only the volume, and then I'll do the surface area, and then when you're ready, unpause, and you can see what I got. Okay, so what we have here, let's dissect this. So first we have our prism base, and that's 2 by 10 by 5. And that would be, so we have the rectangular prism, 2 times 10 times 5, and that is 100 feet cubed. Okay, now these prisms, I've got a sense, are congruent to each other, and these pyramids rather, and it doesn't say anything to indicate otherwise that I can tell. So I'm going to assume these pyramids are congruent to one another. Okay, meaning that each of them has a base of 5. Well, we know it's square, so that makes sense. So that means I've got 2 times the volume of the pyramid, which is equal to 2 times, remember the volume formula, 1/3 times the area of the base times the height, right? You gotta do the area of the base, or 5 squared. Okay, now the 1/3 and the 3 will cancel, so I've got 2 times 5 squared, which is 2 times 25, or in other words 50 feet cubed. So these are 50 feet cubed, this is 100 feet cubed. We add them together, we get 150 feet cubed. Okay, and that just comes from, again, using the 1/3 base times height formula. Okay, and then just putting things together using logic, essentially. Let's talk about, if we can, let's talk about surface area. I'll do that for you. So first of all, I'm going to do the triangles because those are a little bit more difficult. So if we imagine that this is split in half, and we want to find this slant height right here. We need that to find the triangles. And by the way, we know there's again going to be 8 of them, so we just need to find one face. So essentially what we know, if we take a look at this, is we know the base is 5. And we assume that it's split up such that each half is 2.5. So what I have is, if I look at it, this is this from the side, I've got 2.5 and 3. So I've got the slant height squared is equal to 3 squared plus 2.5 squared. Let's go ahead and go to our calculator for that. Okay, folks, I'm back in my calculator. So I've got 3 squared plus 2.5 squared gives me 15.25. Let's take the square root of that, and I get, let's say, 3.91. Okay, so what I have is, for my area of the triangle, I have 5 times 3.91 divided by 2. That's one of them. And then I have 4 for this pyramid, and 4 for this pyramid. So it's 8 total triangles. Okay, so we can cancel, simplify, right, make that 4, and then so we know it's 20, right? We do the 4 times 3.91 approximately. And then what we do from there is we use our calculator to do 20 times 3.91. And we do that, we get approximately 78.2 feet squared. Okay, so that covers the 4 outward facing triangles here. Now we need to figure out the outward facing sides. So here I've got a 10 and a 2. So I've got 20. I've got 2 of those. Then I've got a 5 and a 2. That's 10. I got 2 of those. And then here I got a 10 and a 5. That's 50. And I got 1 of those. So that's 20, 30, 40, 50, 60, 110 feet squared. So I add them, I get a total of 188.2 feet squared. Some people count the bottom as another side. It kind of depends on whether you see that. Some people count that in the surface area. If you wanted to, you would just add another 50 to that, and then you would get 188. So you'd have 188.2. Plus 50, 238.2. Okay, But some people only want to see what's on the surface, so they might not count that stuff that's hidden on the inside. All right. So, next question here. This is one for you to try entirely. A storage container for grain is the shape of a square pyramid with these dimensions shown. What is the volume of the container in cubic centimeters? B. Grain leaks from the container at a rate of 4 cubic centimeters per second. Assuming the container starts completely full, about how many hours does it take until the container is empty? So please pause the video, try to answer A and B, and then when you're ready, unpause, and you can see what I got. All right, so let's take a look here. So basically what we want to do here is to get the volume, remember it's 1/3 times the area of the base times the height. Now the area of the base, since the length is 1, is 1 squared, which is 1, and the height is 1.5. So that would mean it's 1/3 times 1 times 1.5, or 0.5 meters cubed. Now, this is where it gets tricky. Grain leaks from the container at a rate of 4 cubic centimeters per second. Assuming the container starts completely full, how many hours does it take until the container is empty? This is a difficult question. And so to help, we need to take this meters cubed and turn it into cubic centimeters. So what I'm going to do is I'm going to approach this in a different way. To help us, I'm going to look at it like this. So instead of this being a meter, I'm going to look at it as all in terms of centimeters. So that's 100 centimeters. Okay, this is 150 centimeters. So that's essentially using my calculator. A total volume of 500,000 cubic centimeters, because it's 100 times 100, which is 10,000. 10,000 times 50. Okay, so please make sure you understood how I got that, and then it will be a little bit easier. Now, half a meter cubed, what you probably need to know is that there's 100 meters in a centimeter. There's 100 centimeters in a meter. Okay, so if there's 100 centimeters in a meter, then there are 1,000,000 cubic centimeters in a cubic meter, because you would take 100 and cube it. So now it's leaking at a rate of 4 cubic centimeters per second. So 500,000 divided by 4, it's going to take 125,000 seconds. We need that converted to hours. There's 3,600 seconds in an hour. Or you could divide it by 60 to get it to minutes, and then divide it by 60. Okay, so it's going to take about 34 3/4 hours, because I got about 34.72. Okay, so please make sure you understood how I did this one. Feel free to rewind, and then I am going to be moving on at this point. All right, so last one for us to do, and this one is related to an MCAS question. Okay, and as you can see, this is a composite figure. So Robin made a model of a building. The model is composed of a right square pyramid glued exactly onto a right rectangular prism. The model and some of its dimensions are shown in the diagram below. Take note of what they're giving you here for the purposes of this problem. So, the 4 questions we need to answer. What is the volume in cubic inches of the part that is the right rectangular prism? What is the height of the part that is the right square pyramid? What is the part of the volume of the entire model? And then what is the surface area of the entire model? So please pause the video, answer these 4 questions, then when you're ready, unpause, and you'll see what I got. All right, let's break this one down piece by piece, so to speak. So the volume of the right rectangular prism, that would be 10 times 12 times, or rather 14 times 12 times 12. All right, so I'll go to my calculator. So 14 times 12 times 12. 2016 inches cubed. All right. What is the height in inches of the part that is the right square pyramid? What is the height in inches of the part of the model that is the right square pyramid? Okay. Now, we need to figure out the height of this pyramid, right? That's not easy. But let's see what we can do. So what we know is we know that the entire length of this is 12. So if we can imagine this being split in half, as we've seen before, this part is 6. Let me actually make this a little bit bigger. So if you imagine the slant height is 10 inches, and this is 6 inches, then the height squared plus 6 squared equals 10 squared. So the height squared plus 36 equals 100. So the height squared is 64. So the height is 8. In other words, the height of the pyramid is 8 inches. And now let's do the volume of the entire model. So we have, this is the volume of the prism. So the volume of the pyramid, I'll call it pier, is equal to, right, 1/3 the area of the base, which is 12 times 12, or 12 squared. It's the same as the base of the prism, times the height. Okay, let's go to our calculator. 1/3 times 12 squared times 8, 384. Inches cubed. So what we need to do is we need to take these and add them up. So 2016 plus 384. And we get is 2,400 inches cubed. Finally, surface area of the whole model. Lateral surface area. So, the way I interpret this is we need to calculate the surface area of everything that's outward facing. So, we have the slant height here of 10. We have a base of 12. So we have base times height over 2. That gives me 60 inches squared. I have 4 of these. That gets me 240 inches squared. That's the top, right? So you just got to play it by ear and kind of, again, use logic. Here, I've got 14 times 12. So I'll go to my handy dandy calculator. Okay, 168. And I've got 2 of those. So I'll just, off to the side, I'm going to multiply that by 2 and get 336. Then I've got two 12 times 12s, so that's 144. So I've got 288s. Actually, those would be 12 times 14s, wouldn't they? So we've got 12. So actually, this is 1, 2, 3, 4 12 by 14s. So we now have 4 of them. So that would be 672. So I've got 4 of these for 672, the base of 144, and then the top of 240. So we'll add that up. 672 plus 144 plus 240. Or in this case, you could have just used the answer instead of 672. And I get 1056. Again, there is a little bit of interpretation. Inches squared. So hopefully you're able to find this video to be helpful. The idea is to give you a sense of how we're going to do volume and surface area with pyramids. Please make sure you take a look at the assignment for today so you can get a little bit additional practice involving particularly volume of pyramids. But be aware that I am again going to give out a little mini MCAS based assessment next week. And on that assessment, I would expect to see these kinds of questions come up, including questions on surface area. All right, best of luck, folks. Don't forget to love math. And remember,